So our last result is unique factorization. This means that if we have a polynomial a of x with coefficients in some field, then a of x must factor into a product of irreducible polynomials in f of x. And furthermore, if there are two factorizations, and in fact they must be essentially the same thing. That is, the number of factors have to be the same. So r equals s. And after reordering the way it's written, P1 and Q1 will be associates, and so on. So there's two parts to this theorem that we need to prove. One is existence, that we can write a of x as a product of irreducible polynomials. And secondly, that the factorization is unique up to order and associates. So let me do existence first. And this is done using induction on the degree of a of x. And our base case, well, it's a little bit unusual in the sense that we don't start with an a of x of degree 1. We start, our base case instead is if it's irreducible. So if a of x is irreducible, then we are done, because a of x is itself already written as a product of irreducible polynomials. And then our induction step looks like this. Our hypothesis, our induction hypothesis, is that a of x factors into the appropriate way, so into a product of irreducibles, if degree a is strictly less than n. And now we're going to suppose, or maybe I'll call this f of x. F of x factors into a product of irreducible polynomials if the degree of f is less than n. So suppose the degree of a is equal to n. First of all, if a is irreducible, we're done. So I should call that a of x is irreducible. We are done. That's our base case. Otherwise, a of x factors, so it can be written as b of x times c of x, where neither b of x nor c of x is a unit. So it's a proper factorization. So that means that their degree is greater than or equal to 1. And that means that the degree of b of x is less than the degree of a of x, and the degree of c of x is less than the degree of a of x. So by our hypothesis, our induction hypothesis, b of x and c of x factor into irreducibles. And then if we just multiply that together, and we're done. We then have a of x as a product of irreducible polynomials.